Good day. This lesson is about applying MATLAB on some concepts that you have learned in Module 3. We will learn some MATLAB commands that will help you to evaluate, determine, and even sketch graphs of functions that covered in Module 3. Here's the objective of this lesson: to define and use the different syntax of MATLAB and apply it to solving different kinds of concepts and problems in Module 3. The first concept that we will learn is about plotting vector fields. So this is vector field plots in MATLAB. Vector field plots are mainly used to plot the velocity vectors at different positions. To plot vector fields in 2D or in XY coordinate system, the following built-in functions are to be used. Number 1, mesh grid. This command creates a grid of points on which you can plot whatever figures you want. Then we have the syntax. We have in angle bracket, capital letters X, comma Y equals mesh grid of XY. Then we have another syntax, and close in bracket, we have capital letters XYZ equals mesh grid of XYZ separated by commas. The first syntax here returns 2D grid coordinates based on the coordinates contained in vectors X and Y. X is a matrix where each vector is a copy of X, and Y is a matrix where each column is a copy of Y. The grid represents by the coordinates X and Y has length Y rows and length X columns. The second syntax returns a 3D coordinates defined by the vectors X, Y, and Z. The grid represented by X, Y, and Z has size length Y by length X by length Z. The second command that we will use is the built-in function quiver. It is used to plot vector field. Here is the syntax. We have quiver, capital letters X, Y, UV, separated by commas. This syntax plots arrows with directional components U and V at the Cartesian coordinates specified by X and Y. By default, the quiver function scales the arrow lengths so that they do not overlap. Let us have this example. Example 1. Sketch the vector field F given by the equation we have f of xy equals negative yi plus xj. So we have learned how to sketch vector field by point plotting. So let us use MATLAB. So I have here the pre-encoded commands. So in your command window, you're going to type the following. So we have in angle bracket, x comma y equals mesh grid. Then we have the coordinates, x coordinates, and then the y coordinates. So for the x coordinates, you need to assign values, let's say from negative 5 to 5 with a step or increment of 1. Then for the y coordinates, we have values. So you can specify as negative 5 to 5 with an increment of 1. So it is up to you what values are you going to use. Then we have on the second line, we have the U component. which is equal to negative y. And how is this? Because as you can see in the given vector field, we have the first component is negative yi. So that will be the component of your u. Then for component v, so we have here your component j, vector j, which is x. And on the third line, this is supposedly the third line, or I should say the fourth line, because this component u was repeated. So that this is now quiver, you have the quantity x comma y comma u comma v. So take note that when you apply or use those variables, so the same way that you should use them here. So it is, if it is in capital letters, you may use capital letters. If it is written in small letters, you must use small letters. Then when you press enter, this is what you will obtain. So MATLAB will generate this plot of your given vector field. So let us try to, again, type these commands in our MATLAB, and let us check if we have the same figure. So we have here the first command. So the first line, which says us, we have the angle bracket x comma y equals mesh grid. Then we have the x coordinates and y coordinates. So if you're going to just generate this, so you have the table values of x and y. But if you're going to use a semicolon, these table values of x, y will not be produced. So let us check the output when we have the semicolon. Then I place a semicolon. So this is the result. So for you not to display these table values of x and y, you may use the semicolon. I have typed here the other commands. We have the component of u and component of v. So it can be found by having the equation of your vector field. So we have, for the component of u, it is the vector I, which is negative y. And for component v, it is the vector j. Then we have the x. And then we have the command quiver, and close in parentheses, we have now x, y, u, v separated by comma. Then when you now type enter, so let us observe what will happen. So we can see here the plot of the given vector field. So you can try to zoom to check the image of the given vector field. Then you may use the zoom out to back to its original figure. So as you can see, we have the limits given us from -5 to 5 for the x coordinates and -5 to 5 for the y coordinates. So this is how we plot the first vector field. Let us try another example. Let us have the second example. We're going to sketch the given vector field f of xy equals xy. So in your command window, we're going to use the same commands that we have used in plotting the first vector field. So in here, I will use again the same values of x coordinates and y coordinates. Then, but this time, our u component will just simply x, because that's the first component in your vector field, and the v component is your y, because that's the second component in your vector field. Then you will use the command quiver to plot the vector field. So we have here now quiver, then we have enclosed in parentheses, we have the variables x, y, u, v separated by comma. Then when you press enter, this is the output provided by MATLAB. So let us again encode the following commands in our MATLAB and check if we have the same answer. So I want to clear my command window. So I will use the command clear, comma, and then this is clearing the workspace. Then I want to clear now my command window. So let us now generate the command window, the commands in the command window. So we have here I have here the first command in the first line of your command window. So you can just use the arrow and down keys to have your encode or you have your command be written in your command window. Then let's have our U, component U. So component U, this time it is equal to X, as can be seen from the given vector field. Then we have component B is equal to Y. Then let us use the command quiver and type the argument xy separated by comma including u, v. Then type enter. So as we can see, the figure now is replaced, the old figure is replaced by a new figure. So this is the graph of your given vector field, whose equation is, we have it as xy. So this is how we sketch vector field using MATLAB. Then we go now to the second command, which is curl of a vector field. So we have learned this in our lesson. So the curl command is curl of vector field. Then we have here the syntax, curl, open close parentheses, v, comma, x. Or just simply curl, open and close parentheses, v. So the first syntax returns the curl of the vector field v with respect to the vector x. Then we have the vector found, or the vector field v, and the vector x are both three-dimensional. Then the second syntax returns the curl of the vector field v with respect to the vector of variables returned by simvar v. So I will use the first syntax. Let's have this example. So if we're going to find the curl of the vector field, so the given vector field has the equation 2x squared yi plus 2y cubed zj plus 3z squared k. So manually, we compute the curl of your vector field by having a matrix which is a 3 by 3. Then we apply a basket method or the formula that we have learned. And the answer here is negative 2y cubed I minus 2x squared k. Now using MATLAB, what you will do is just to use this command. So let us have these commands in your command window. So we have here, the first line is sims xyz. So we need to declare the variables given in your vector field. So we use the sims command. So this involves three variables. So we have here three variables x, y, z. Then in the second line, we have the equation of your vector field represented by capital letter V is equal to, so we have here in angle bracket, we have now the first component to be 2x squared y. So we need to use the necessary operations in MATLAB, such as we have the asterisk, which is about multiplication, and then the caret, which is raising to a power. Then we have the second component. So you encode this as 2 asterisk y caret 3 asterisk z. Then the third component, we have it as 3 asterisk z caret 2. Then a semicolon. So take note that these components of your vector field are separated by commas. Then for the vector x, so this will be the variables that we have used in the given vector field. So enclosed by bracket, we have it as x, y, z, and they are separated by using space. Then another semicolon. Then after that, you're going to type now curl and open and close parentheses, capital V and capital X separated by comma. And this is what MATLAB will display. So we have the following answer in this form. So it's negative 2y cubed for the first component, then 0 for the second component. For the third component, we have negative 2x squared. So as you can see, we have the same answer. So again, let us type the following command in your command window. So let us type again clear and CLC to clear the workspace and clear the command window. So let us now type sims x, y, z. Then we have your vector field equals the angle bracket, or not angle bracket, but it is bracket. So we have 2 asterisk x caret 2, comma, then 2 asterisk y caret 3, then asterisk z, comma, then we have 3 asterisk z caret 2, then the close bracket. Then we have the semicolon. Then let's have x equals, you have x, y, z, semicolon. Then we now use the command curl to evaluate the curl of this given vector field. So we have capital letter V for the vector field that we have used, then capital X for the variables. So let us just press enter now. So this is the answer obtained. So I committed a mistake here. So we have negative 2y cubed, 0, and then 0. Let us check what I have used in the given vector field. I have found my error here. So for the first component of your vector field, I have typed it as 2x squared instead of 2x squared y. For the second component, it is 2y cubed, say that's correct. Then 3z squared for the third component of your vector field. So anyway, this will be the answer if we have this as our given vector field. I have here now the corrected vector field components. So we have here 2x squared y, then 2y cubed z, and then 3z squared. Then I have tried not to place semicolon in your second line, which is you have here the variables represented by x, y, z, and this is what you will obtain. So better that you will use a semicolon. Then we have here the curl command to compute the curl of this vector field. So let us press enter and check the output if we have the same answer. So as you can see, we have here now negative 2y cubed, then 0, then negative 2x squared. So we can use the command pretty to have our answer just like what we usually use or write these expressions. So as you can see, we have here now negative 2y cubed, 0, and negative 2x squared. Let us work on another example. A while ago, we have two syntax for the command curl. So in the first example, I have used the first syntax. For the second example, let us use the second syntax. So this is just curl of open and close parentheses v. So v represents the vector field. I have here the second example. We're going to find the curl of the vector field f of xyz equals x squared yi plus 2y cubed zj plus 3zk. So in your command window, again type sims xyz, but since you have already declared the variables xyz, so it's okay if you will not anymore declare that. Then you go now to your vector field. So as you can see, the given vector field is f. So you can use a variable f. Then equal to, in the bracket form, we have it as x squared y as your first component. Take note that you should use parentheses in some components of your vector field. This is how we express these expressions in MATLAB. Because if you will not use parentheses, MATLAB may interpret the given, may have another interpretation rather, on the given vector field f. So it is necessary to place parentheses. So as you can see in the first component, I have here parentheses x caret 2 asterisk y, comma, then the second component I have here 2 asterisk open close parentheses y caret 3 asterisk z, comma, then the third component is 3 asterisk z. Then do not forget the semicolon. So this will suppress the output from your command window. Then we have the command curl now, curl f. This is the second syntax. And this is the answer. So we have negative 2y cubed as the first component, then 0 as the second component, then negative x squared as the third component for the curl of this vector field. So let us again type these commands in our command window. So I have here already the commands. I have pre-encoded it. So let us check the output if we have the same answer. So there is a typo error here. So I use curl F. So be careful when you type the command in your command window. So as you can see, this is the answer, negative 2 asterisk y cubed, then we have 0, then we have negative x squared. Again, you can use pretty so that the displayed output resembles to that of what we usually write. So we have here now negative 2y cubed 0 and negative x squared. In computing the divergence of a vector field, so we have also the built-in command divergence in MATLAB. So divergence is divergence of vector field. So for the syntax, we just have to type divergence, small letters, then the arguments, we have capital V, comma X. So we have here the description of the following syntax. It says here, it returns the divergence of vector field V with respect to the vector X in Cartesian coordinates. Vector V and X must have the same length. So let us have an example. So from the previous vector field that we have used in example 1, we're going to find the divergence of that vector field. So we have here the vector field given is we have negative or positive 2x squared yi plus 2y cubed zj plus 3z squared k. So this is how we compute the divergence of the vector field. So we use the formula. We are to just differentiate the first component with respect to x plus the partial derivative of the second component with respect to y, then the partial derivative of the third component with respect to z. And this is what we will obtain. It is 4xy plus 6y squared z plus 6z. So in your command window, so again, type the command simsxyz. Then you have the vector field v with its components. Then we have the variable x with variables x, y, z. And then we use now the command divergence. And this is what we obtained. So it is negative, or rather positive 6z y squared plus 4xy plus 6z. So again, let us type this in our command window. I have already encoded the following commands in my command window. So again, you type sims xyz, then the given vector field v. So observe that in here, I did not use sets of parentheses for each component, but just to be sure of your answer in MATLAB, you must also check it using manual computations. Then we have the variable x declared as x equals in bracket form xyz semicolon. Then we have the command divergence. Then open and close parentheses, your vector v and your vector x separated by comma. Then just press enter. So it is what we obtained from the command window. So it is negative z, or rather 6 zy squared, then plus 4xy plus 6z. So if you can see here, the answer and the answer here, they are the same, but the appearance are different. So we can conclude that they are the same or they have the same answer. So you can use again pretty answer and we have the following output. It is just simply 6z plus 6y squared z plus 4xy. So these are the commands that we will use to evaluate some concepts that we have learned in Module 3 using MATLAB.